Welcome to the next session on Module 4. In this session, we will be dealing with how ozone is formed in the atmosphere, about the depletion of ozone layer, its ill effects and control measures to prevent the depletion of ozone layer. Secondary air pollutants we have already seen in the previous sessions. They are those which are not directly released into the atmosphere but forms when primary pollutants react in the atmosphere. So for example, nitric acid, sulfuric acid, they are formed when sulfur dioxide or sulfur trioxide as well as oxides of nitrogen, when they react with water vapor present in the atmosphere, it results in the formation of these acids. Similarly, ozone, it is also a secondary air pollutant. Ozone, it is a triatomic oxygen molecule. Why it is called a triatomic oxygen molecule? Because it has 3 oxygen atoms. Its formula is O3. It forms a protective layer in the stratosphere which absorbs harmful UV radiations from the sun. And thickness of ozone layer, it is about 3 mm and it is called ozonosphere. Now let us see how ozone is formed in the stratosphere. It is formed by the photodissociation of oxygen molecule. Photodissociation means dissociation in presence of light. So, oxygen molecule, it absorbs UV radiations of about 240 nanometer wavelength and it dissociates into 2 oxygen atoms. The atomic oxygen, it will combine with molecular oxygen producing ozone. So, this is how ozone, it is formed in the stratosphere. Now, ground level ozone, it is formed when primary pollutants such as oxides of nitrogen, that is nitric oxide, nitrogen dioxide, etc., and volatile organic compounds react with sunlight. Volatile organic compounds means ethyl alcohol, benzene, etc., which are present in paints, cleansers, air fresheners, disinfectants, moth repellents, etc. All these constitute volatile organic compounds. So, when oxides of nitrogen and volatile organic compounds, when they react in presence of sunlight, it results in the formation of ozone. So, this is how ozone is formed in the stratosphere as well as at ground level. Now, let us see the effects of ozone layer. Positive effect is that UV radiation, which causes skin cancer, eye disorders, then which suppresses the immune system. All these, it can be prevented by ozone layer. Ozone layer, it prevents the UV rays from reaching the earth's surface and thus it is beneficial for both plants as well as animals. The negative effect is that it is having a very high oxidizing potential and hence it can damage the mucus and respiratory tissues in animals and also tissues in plants, because ozone, it can penetrate the cell membrane and thereby it can affect the lipoproteins and lipopolysaccharides and thus affect the tissues. So, this is the negative effect of ozone. Now, how to control ground level ozone? Ground level ozone, it can be controlled by capturing and treating oxides of nitrogen and volatile organic compounds from industrial and automobile exhaust. By capturing and treating them and converting it into less harmless products, ground level ozone, it can be controlled. Now, depletion of ozone layer. Ozone depleting substances include chlorofluorocarbons and volatile organic compounds. Chlorofluorocarbons or freons, they are used as coolants in refrigeration and air conditioning. They are very stable on Earth and they slowly drift into stratosphere. They react with the UV radiation to form chlorine-free radical, which is a main potential ozone depleting species. So, this is the reaction that is taking place. So, CF2Cl2, that is dichloro-difluorocarbon, which is generally called freon. This freon, in presence of UV radiation, it results in the formation of chlorine free radical and CF2Cl. And this chlorine free radical, again it will combine with ozone. Chlorine free radical thus generated, it will combine with ozone and form chlorine monoxide radicals and oxygen. This chlorine monoxide radical, again it will combine with atomic oxygen and forms chlorine free radical and oxygen. Thus chlorine radical, free radical, it is regenerated and it causes breakdown of ozone. This chlorine free radical, again it will combine with ozone molecule and result in the formation of chlorine monoxide and oxygen. Thus chlorine monoxide free radical, again it will combine with atomic oxygen and form chlorine free radical. Thus this chlorine free radical, it is continuously regenerated and this causes the breakdown of ozone. Thus chlorine free radicals will continue this chain reaction, and the CFCs, these chlorine free radicals, they are initially formed from chlorofluorocarbons. Thus chlorofluorocarbons, they are the transporting radicals into the stratosphere and they damage the ozone layer. It results in the formation of holes in ozone layer. Now ill effects. Depletion of ozone layer, it results in the formation of holes in the layer which enables the harmful UV rays to enter the Earth atmosphere. And if UV radiations enter, it can lead to skin cancer, it can damage the immune system, it results in accelerated aging of the skin, eye disorders, decrease in long range agricultural productivity. And how to control? Alternatives for CFCs include hydrofluorocarbons and hydrofluoroalkanes. These substances, they contain hydrogen atoms in the molecule and they undergo degradation before reaching the stratosphere. So ozone depletion potential of HFA or hydrofluoroalkane, it is found to be 0 since it has no chlorine atom. And this HFA, it is used as propellant in inhalers. Earlier CFCs were used as propellant to spray the medicine out of the inhaler, but now CFCs have been replaced by hydrofluoroalkanes. And hydrofluoroalkanes or hydrofluorocarbons, they are more effective because they don't contain chlorine atom, and hence the ozone depletion potential, it is 0 for them. So they can prevent the depletion of ozone layer. So that's it. Thank you.